welcome everyone. Thanks. Thanks for coming down for this talk. You can't hear me at all, or we've got to use the mic. So I'll have some demos. I won't be able to use the mic for those. So now, first of all, sorry for being the first talk after lunch. I guess it's a little bit difficult. What's more difficult than attending a talk after lunch is giving a talk after lunch. So bear with me. I'm going to give you quite of a big warning. We're not going to look too much into the internals of Docker in this talk. We're going to be focusing more on Linux containers, okay, and not just Docker. Because my opinion, Docker is here. I don't know if it's here to stay for the next 5 to 10 years. Containers will definitely be. Now, this talk is for those who are now playing with containers. We just started working on them. We just started trying to move and migrate the replication to containers. For the ones who are trying to figure out the mess out of containers, and for the ones who've never heard of them, okay? So now, how many people here in this room have never played with Docker? We got a bunch of people, so I'm going to go ahead with the first demo. So I hope you guys will be able to read everything out here. We're just going to create a small Node.js app. We'll Dockerize it, and we'll have it running on our system. So, you can't really hear me like this? No. Oh, just come forward. I like to see you, you know. So I'm in my TMP folder because I'm not the kind of commitment guy. So I'm gonna say, let's create a demo folder. Okay, let's go inside. Let's create a very, very simple Node.js server. Okay. This is gonna take us no time. We'll have this guy running on port 3000, and well, guess what? It's not gonna do anything groundbreaking. Okay. There we go, rest right. 1, 2, 3, 4, and we're done. Okay, now I could easily run this kind of guy on my system, but I don't want to install Node on my system. I don't have it running. I really don't care. I'm just going to use Docker because I think it makes so much more sense. So the way I'm going to run it, I'm going to create a Docker file, and I'm going to say from Alpine Linux. How many of you know Alpine Linux? It's a very, very tiny distribution. It fits in I think 5 or 12 megabytes, and it's security focused. So it's a very tiny and very security focused distribution. I'm gonna say, hey, now run apk add. Oh yeah. One sec. I'm kind of. Alright? Yeah? Alright. So, we're gonna install nodes inside a container. So this will live in its own container. This is just like an apt-get, just like for Alpine Linux. Then we're gonna say, copy all the files that are in my current folder inside source inside the container. And then your command to run, when this container will run, will execute node source index.js. Okay? Now I'm going to build my container. It takes no time. Okay? So generally Docker will take a little bit of time to build this container for the first time. Next time we're going to be doing that. It takes no time because those steps are already cached. Let's try. Docker run minus, oops. Yeah, code motion. Now this guy will never run. Okay? I'm gonna go to localhost 3000 because it runs on a separate network. Okay, it runs on a separate network, so the host doesn't really see the container running. So what we need to do is just to say, look, expose port 3000 outside of the host, in the host, and remap it with port 3000 inside a container. Boom. Okay, nothing more, nothing less. Now, the trickery here is that, for example, for development environment, the crazy good thing about Docker is that you can run your whole development environment in Docker, and edit files locally and so on. So now what you can do is, for example, let's mount a volume, okay? The volume would be the current folder, and we remap it into the source folder, okay? So now if I open another shell, let's go inside demo. This guy is still running, okay? We're doing an index.js. We're just gonna change this guy to do, just read a file from the file system. I'm gonna use read file sync because I'm a bad guy. Okay. Okay, now tricky part is I would have to rebuild this container now. Okay. When I run it, there we go. So this application is just pressed. There is no text dot blah 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 in here. So we're just gonna create it as .txt. Okay, let's try to rerun it. Oh, what happened? Cannot open test.txt. Now this is what scares the shit out of me for demos. Okay. Let me try to do something. Yep. Okay, I'm really bad. Can anyone see what's not working? Oh, fuck my life. Okay. Yeah, of course. Because inside a container, we're running it inside the source folder. So let me just check if this guy will work now. I'm going to run the container. Now, what you can do is I'm going to get inside the container itself. Okay. Let's we've got this guy, so let's see. It will finally run. Perfect. Now I can do a source test.txt. Okay, nothing more, nothing less. So we've just updated a file in the container. Now these guys have like some more features, some more interesting features, like you can mount a container with a read-only file system, so you cannot really modify files inside a container. Now, I think one of the interesting parts of running Docker locally is actually using Docker Compose or any of the local orchestration tools. So, because this is a lot of shell voodoo that you will not want to type manually every time, right? So, I'm just going to go ahead and create a Docker Compose file. So, I'm just going to say, this is my service. It's a simple web server, okay? It builds the current folder. It will also expose a port. Okay, for 3000 onto 3000. It will also export a volume because you will want to edit that code locally, okay? So I'm just going to say on this volume, into source. Let's pray this works. Okay, and it's there. Now you don't have to remember any command at all, and boom, you have your stuff running locally. Now the interesting stuff, and I don't really have to remember a lot of stuff. I can just use Fig or Docker Compose, these small orchestration tools, and it will work out of the box. Now, getting back to the presentation, and now I can build this image, build this container, deploy it to production. It will have the same exact stuff that it has locally, you know. So you're abstracting your local development environment from you know, your machine itself. We're going to be looking at a lot of container laws or directives in this presentation. So every time you see this slide, is some opinionated thought that I have about containers. First of all, we would be wondering, you know, why would we use a container for this stuff? Because I can install everything on my system. I can use a VM in production and so on. Now, the most important part is remember the first time you've ever built a web server with Node. You're like, oh shit. Now it's 3 lines of JavaScript, and this thing responds to the browser, you know. Or the first time you've used Angular, and you're like, oh wow, okay, this thing lets me prototype in really no time. Or you know, like the first time you launch a Go routine with Go function, and boom, this guy's go behind your back and executes in parallel, and blah blah yada yada yada. Now, compare this kind of work to reinstalling Nginx in production. all right, to installing curl because you have to debug something on a production server, or to increase the ulimit, the max file that you can connect to, because your tasks are opening too many files and yada yada yada. Now, this thing is not really fun. Systems are quite boring, and I would say they're quite freaking boring. Okay. The problem is there is a duality. You know, code is like a pilot. You know, you'll have a unique style. It's going to be hard to replicate. You know, like you'll be developing code for a feature. You can abstract as much as you want. Okay. But then to develop another feature, you'll need like some different sets of logic, some different sets of rules. So like all of that stuff will be totally different. So systems instead are the F1 car. Now, the nice thing about the F1 car is not that, you know, during a pit stop you change the tires, you know, because that's just like a little bit hectic. It's 5 seconds and it's done. And you wish you wouldn't have to do that in the first place, right? You know, like cars need to be robust, reliable. They need to be replicable, you know, like, so if someone who crashes the car in one track, then the week after you'll need to rebuild the same exact car and give it to the same exact pilot, okay? And this is the duality that I was talking about between systems and code. You know, like fun things that you can do on systems are different than the things that you do with code. And systems are not nice to build because typing apt get and that kind of stuff bores the hell out of me, and I hope it bores the hell out of you too. But they are nice to orchestrate. You know, when we create an environment, a complete stack that, you know, we can replicate with one command, that it's resilient, that supports a dystopian architecture. If a machine goes down, you don't really care. You know, that's the kind of nice stuff that you do with systems. And we've been building, you know, a lot of tools to do that in the past. And what all these tools have in common, you know, is maybe Vagrant is more for development environment. The other guys, you use them like to provision machines in production. But what's common between these guys that they take care of VMs, okay? Or even like, you know, bare metal. But in general, you just rent a VM on Amazon, you use Puppet to provision it, SaltStack or Ansible. Now, Vagrant has a driver for containers, but, you know, it wasn't really built for that. And the real problem is that I see that not a lot of people know what are the exact difference between containers and VM. Now, what people say is, it's usually, look, a container is exactly like a VM, okay? It's just a little bit more lightweight. It's a little bit of fluff. It is somehow true, it is somehow false, because you've got to understand, you know, like what's the difference in between. A container shares the kernel, okay, with the host system. So they use the exact same kernel. So a syscall on a container is potentially a syscall on the host, okay? Now, VMs are completely different. You know, resources allocated to a container, they get allocated to the host, but there is not as much isolation as you would get with a VM. With a VM, you specify a fixed size, and that's what you get. Containers are different, okay? You can specify a cap, a limit, but if you've ever used, you know, like Docker resource limiting, if you ever use LXC's resource limiting, you would bump into a lot of problems, okay? Especially at scale. They're not the same as VM. Isolation is completely different, you know? There are parts of the file system of the host that are mounted and are writable into the container, like proc sys, you know? They share the same exact file system in there. They're mounted, so you can basically access the host from the container. Now, there are ways to limit this because it's not as scary, but it's not as isolated as a VM, which is a completely different, you know, system running on top of another host. And of course, security is much different. Now, they share the same kernel, so potentially there could be scenarios where containers can escalate to the OS. And that could also happen with VMs, but it's much, much, much harder because of the way the architecture works, you know? And I really like what the Docker guys say, is that they have similar benefits, and they tend to solve like very similar problems. It's just the approach that containers have, they're much more different. And now, this is like the first law that we should really, really remember. Containers and VMs are not the same thing. They don't always solve the same problems, okay? They were built to fix similar problems, but also their use cases are much different and fundamentally are two very different systems that run. Now, if you're familiar with this guy, this is the Beige dolphin that disappeared from Earth in 1996. So I needed a reference for 1996, and I figured out this would be pretty much educational. So same year at Google, they started to work on C groups, okay, also known as control groups, which basically it's a feature of the Linux kernel to be able to give a set of processes isolated resources, so RAM, so CPU, and let them use those resources in isolation. So, and this is 2006. They actually made it to the main line of the kernel, I think in 2008 or something. Now, and out of those, once the kernel also got namespaces which provide, like isolation for those processes in terms of I cannot see processes outside of my namespace. We've got LXC, so the Linux container project that first started as a driver for containers. So if you ever used this thing in production, you would have probably hurt yourself a lot because it was quite unstable, and we've got like players like what's the name? .cloud, players like coding.com that tried LXC in production and had to switch back to VMs because at that time they weren't as stable. Now we've got a company like .cloud. It's basically it was, I think, basically an alternative of Heroku. They would let you, distribute your architecture on the cloud, on the spot. So they would want to provision systems for you like very efficiently. So they thought, what could we use to let our customer provision systems like with ease? They tried VMs. They were slow, yada yada yada. And then this guy, Solomon Hykes, CEO of .cloud back in the day, and now CTO of the Docker Inc., decided to actually hack on a tool that would be using LXC at the beginning, and then would evolve in its own container runtime. Okay, and that tool was Docker, and this was like I think not longer than 3-4 years ago. It's very very recent. Okay. After that, the Docker guys realized, look, the LXC implementation sucks so hard. Okay, it's very hard to handle it in production. It's pretty buggy. Resource isolation doesn't really work as much as we would like to. So let's rewrite our own container engine, our own container runtime. It's called libcontainer. And this was like, I think, a terrific step for them to get to a more stable product. I really like libcontainer as a project. So now, just to give you a perspective, this is the engine that Docker runs on. Because they have very, very interesting, values in terms of software development, like less code is better. If you can't document it, don't release it. I think it's a very well thought piece of software. I would recommend everyone to have a look at the repos. And then in recent years, I think last year, 1.5 years ago, we've got like a standardization of the container ecosystem, which is still going on. So they came out with a spec for runc, which is a spec on how to run containers. They came out with appc, which is a spec on how to build images for containers. So Docker is not the only player in the container environment. You've got like other player. CoreOS is building it's massively dedicating a lot of the resources into building Rocket, a competitor for Docker. So we're only going to get more of that on the long run. And the way you think about it now, Docker is not going to be there for very long. There is a lot of talks on how to rewrite the way Docker is implemented. Now it runs with a client, which is the one that I use to trigger commands on my machine, and the daemon, which is basically a server that accepts those commands from the machine, from the client, and then runs the containers. Okay, so the way Docker is being built might not be there for a long time. Rocket has proposed a very different and I think overall better approach. So it could very well be that 2-3 years down the line, you won't be using Docker containers at all. We'll be using Linux containers, but not with Docker. And now, think of Docker being, that simple, okay? And we've looked at the demo. I was actually planning of doing the demo right now. Docker is that simple, I wouldn't know any other way I can build an application and run it on my local machine and be able to run it on my staging environment, live environment, with the same exact image, with the same exact specs, with just a Docker file. I don't think there is any other platform, there is any other tool right now that can give you that simplicity overall. And it just doesn't stop at having Docker running on your dev environment. You know, like you've got, as you saw, we've got a Docker Compose files that you can use to orchestrate your development environments, so you don't have to remember all those commands and so on. So I think they've done like a huge amount of work to simplify the way we think of building systems right now. And if you expand your horizon a little bit, you can do things that are a little bit more complicated with Docker. So I've got like a very simple example. Now I'm going to be running again this server. Okay. Perfect. Let's see if it's up right here. Perfect. I'm going to run ngrok on port 3000. Do you know what ngrok is? Okay. Have you ever needed to develop something, some webhook, for example, for the GitHub API, so that GitHub would, you know, notify you back and you run something on your infrastructure? You know, like there is an external system that sits on the internet that wants to talk to, you know, one of your systems. Now, when you develop that thing, you're developing it locally. So how can you tell GitHub, hey, this is the address of my machine? So you just use ngrok, which is a thing that tunnels your local, one of the local ports to the internet. So it's a pretty amazing tool, actually. Oops. So here I have the address of my tunnel. Okay, now my thing is exposed to the internet. Now, what's interesting about this is, well, first of all, I think ngrok is a great piece of software, but the other interesting thing is that I've not installed ngrok locally at all. I just have it running through Docker. Okay, so I don't really want to know how to configure this shit, how to do this and that and that. I'm just going to use a container for that, you know. And I think this is one of the beauties of Docker. There's a container for everything. Okay, so you just take a piece of already bundled image, you run it locally, and you're set. We have Docker running in our system. We're developing a Node app without Node because I don't need it installed on my system. We're exposing it from our container to the host, and then we're running ngrok to expose the host to the internet without ngrok at all. You know, I'm just running it through a container. Our machine is exactly like a virgin. I really love this slide because I don't need to install anything. You know, I just need a bunch of files on my machine and I'm set. You know, I don't need complicated setups and so on. There are like crazy people, I think, pretty crazy, that run Chrome on Docker, you know? You just share the X server. Boom. You know? And this is just one of the possibilities that you can use Docker for. It's not just to deploy your applications in production. It's just a simplified way to run applications. You know? And at that point, my machine really just needs to have some files, and I'm set. Now, let's tear this thing down. And next, it's a very interesting story. So at some point, I don't know what you guys use for log management or whatsoever. We wanted to have something. We thought of the ELK stack, Elasticsearch, Logstash, Kibana, blah, blah, blah. We made a terrible call to go for, law number 3, my bad. So we don't really need to use containers just for live or staging or orchestrating our applications. They fit a lot of use cases that we can think of. Now, this is the story I was talking about. We decided to make a terrible call and go for Graylog, which is a thingy that runs like a lot of moving parts to just collect logs and display them on a nice interface. Now, the first thing I had to do back in the day was 4 years ago. I just had to install Mongo, then start the Mongo thingy, change like some stuff in my deb repositories, install Java, which I always don't like, then wget something, change again my deb repos, install Elasticsearch, start Elasticsearch, change Elasticsearch configuration file, yada, 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 configure some more thing, go grab a coffee, wait for apt-get to finish, start Graylog. I'm like, oh, finally, Graylog is up and running. Oh, but shit, I need a web interface now for it. The server is up and running. I need a web interface to actually look at those logs. Then I finally finish. I'm welcome with that interface. And I'm like, I'm so happy about what I just did. And the worst thing was the face on, our lead system administrator when I told them, look, dude, we have to do this in production. He just looked at me and he just basically wanted me to vanish at that point. Because you can't really think of managing your systems in that way. What you would do right now is Docker pull, Greylock all in one, and you're set. Okay? So it really makes it easy to run this kind of systems. Because Docker files, a list of instructions, a list of scripts that you just run on a machine, okay, or on a set of containers. When I say machine, I mean a container, are just the simplest form of configuration management. You basically need volumes and ports to talk to each other, okay, but then basically just Linux systems with commands that you run on top of them. The tricky bit, I think, of containers is that orchestrating them might be a pain in the ass, okay, literally. But to be fair, it's the fun part. We looked earlier at, how we would build a container locally. It's very easy. It's very simple. There's no fun in that after a while. We've seen that, we don't want to configure our systems on live as well. And the orchestration part is actually the nice part, and this is what makes it, what is really hard in terms of containers, because you will want that if a container dies, if a machine goes down, that shouldn't affect the rest, the state of your architecture. Your orchestrator should be able to say, hey, give me another machine, I'm going to run the same exact containers there. Because they're also very easy to boot, so this thing can happen in 5 seconds rather than 2 minutes. And we personally decided to go for Kubernetes, essentially because of one reason. It's a system that comes down from Google. And by the time I would have finished this exact sentence, Google would have now spawned 35,000 containers, because they launched 3,300 containers per second. Okay? They run something like 2 billion containers a week. And it's not, just like that they started the work on C groups, because these guys wanted to, make the development experience much, much better. They wanted to be able to run systems very fast, to boot them very fast, and that is why, Google has pushed a lot on this. Now, they use a system called Borg internally since, I think, 9 years, and it's an orchestrator for containers. And they released, just like a year and a half ago, Kubernetes, which is basically their open source version of Borg. It's not really the open source version. It's a rewrite from scratch, because I can only imagine what kind of monster they have that runs internally. So they released this platform so that everyone could use them. Now, the nice thing is that, for example, they integrated it on their Google Container Engine. So you can just run Kubernetes natively on the Google Container Engine. So it's one more customer for them if you're using Kubernetes and you want to use a hosted infrastructure. You can host it on your own. That's what we do, for example. So now, Kubernetes is no Docker Compose at all. Okay, it's slightly more complicated, but that's because it's built for a massive, scale that organizations like Google have. So this is, for example, a replication controller, which I will explain later what it is. And just by the fact that I have to explain what it is, you'll understand that it's not that easy. It's not that simple to begin with. But what is really interesting for us is that 2 things. This guy tells me, I want one replica of this guy, and I have one container in this controller, and it's an Node.js app. It exposes this port, and that's it. Okay? So at the end, when you boil it down to just these 2 instructions, you understand that it's, we're talking the same language that Docker Compose talks, even though there's a lot of other stuff that sometimes it's a bit useless. So the way you run the service, you tell the Kubernetes, Controller, create a service from a file. This is my definition. And this guy will start the container for you. Now, the way Kubernetes is set up, you just boot a cluster of machines, okay? You give one of these machines the role of master, the Kubernetes master, and then the other ones will be the Kubernetes slaves, okay? And on these slaves, you'll have this sentinels that are running called kubelets, okay? And it's basically, they're just going to talk to the master to understand which containers they have to spawn out, which containers they have to tear down, what's we need to do with this, that, and so on. So it's basically just like boot some machines, give them to Kubernetes, and Kubernetes will take care of creating the architecture for you. And sorry for the ugly slide. And overall, it really boils down to 3 definitions. Now, they just released 1.2, Kubernetes 1.2 yesterday, which changes in the name of replication controllers to replica sets and so on. So there is still a lot of work going on. But basically, you can boil all of this down to basically 3 entities. Okay, there is more. There is more to look at. But like for the common use cases, like for us, what would be for you, you just have like to deal with these 3 guys. Pods, which is a set of logically linked containers, okay? Which is hard to digest. It means a pod is a subsystem that runs 1 or X containers that need to sit together. For example, you will want to deploy MySQL on a container. I mean, you really don't want to do it, but if you want, you can. And that's a pod, okay? You will want to deploy an Node.js app, but because you want Nginx on top of it to implement whatever, caching, to implement something else, these 2 guys will always work together, okay? So this pod will have 2 containers running. So as I said, it's not as straightforward as, like the way you would orchestrate it with Docker Compose. It has some more concepts. And, like a pod is simply, a set of containers that need to run with each other, okay? Now, we have 2 separate pods here, MySQL and this Node Nginx guy. And now, to orchestrate them, to boot them, to understand like how many of them should be running, we have replication controllers, which are those files that I showed you earlier, and talk to the Kubernetes master and tell them, hey, look, how many of these guys, how many of these pods do I have running in the architecture across the cluster? I have 1 of them, but if I know that I have to run 2 of them, let me boot up a new one, okay? Then Kubernetes has a scheduler, and the replication controller will tell Kube, hey, schedule another container, okay? So this replication controller is literally just the guy who makes sure that pods are up and running in the right units, in the right number, across different machines. Make sure that you won't schedule the same pods on the same machines if possible, and that's it. So they're basically like health checkers, nothing more than that. And as you see, we've got the replicas defined in the replication controller. Now we just tell Kube controller scale my app to 2, and these guys will just scale the application like you would expect. Like very simple. Now this whole thing takes like 5 seconds. So, and mostly due to the time that it takes for your application to boot, and not like for Kubernetes to schedule it. And then you've got services, because the problem in this picture, this is very nice, but the internet is over there. So how do you talk to these guys, and how do these guys talk together, especially if they're distributed over a set of machines? Now you've got services for that. So services are just load balancers, okay? So they provide you an endpoint to reach a service, It's not a pod, a service. So this would be service MySQL. You could have like 30 pods running behind it, but when you're like, hey, is my MySQL service up? You don't care about those 30 pods. You care about there's 1 pod at least behind the service, because it's the service that you're talking about. Okay, same thing for Nginx. Now, this makes it easy for people from the internet to connect to this guy, but how will the Node apps talk to MySQL? Okay, we still haven't fixed the problem. Well, Kubernetes, I think, through a tool called Flannel, does it for you. So across 4 or 5 or 10 or 20 machines, it creates an overlay network, okay? So all those machines can see each other like if they were under the same network, like if that's just 1 machine. It will give them an IP that will never change. And you're like, oh, now I am the Nginx pod. I want to run a query to MySQL. So what's the address of MySQL? It's 10.1.1.1. And even if that guy is on another machine somewhere else, even on another data center, okay, in another data center, maybe not. But if it's on another machine, you don't really care, because the overlay network will make that available for you. So you just connect to that host on port 3000, 3006, whatever, and you're going to be into MySQL. nothing more, nothing less. And it's very efficient in terms of networking. Like, maybe you lose a millisecond over running the same application on the same host. And as I said, Kubernetes will, based on your directives, decide how am I going to fit all of your architecture in your hosts. You'll tell it, hey, I want all containers of one type in one machine. Bad idea, but could do it. Or try to distribute them as much as possible. Or do not put more than one replica of the same pod on one machine. And based on those directives, it will decide how to schedule them. It might be that the node containers will sit on the same machine in MySQL somewhere else. It might be that one MySQL pod and one node pod will sit on another machine, and there's going to be another guy. The interesting thing is that you will never know where those pods are scheduled, okay? Because you don't want to talk in terms of hardware. You want to know that your services are up and running. So you let the orchestrator do that for you. It could be that you only have one node, and all the pods go there. And now you're fucked, because when that node goes down, you're screwed, okay? So that's not a good idea. The data center, the way we thought of it, is changing, okay? This is the way we're going to be running the data center of the future. Now, think about one thing. When Amazon, by the way, 3-4 days ago, it was like the 10th year anniversary of S3. So you've seen Amazon coming out with products that revolutionize the way we think of like computing. That you can just rent hardware or rent a virtual machine and you're happy with it, right? Because you don't have to manage it. It's so convenient. Now, the same way we have been exposed to revolutions in terms of running and getting virtual machines up and running with our softwares, the same revolution is going to happen for data centers. You will not want to talk about machines. You want the orchestrator to do that for you. You just need to set up a cluster, tell it, hey, this is my base image for my cluster. It could be CoreOS, it could be whatever. And then put it in an auto-scaling group so that when you deploy more containers, the auto-scaling group will add a new machine. You have Kubernetes, you'll have auto-scaling on Kubernetes, and that's it. You don't really want to deal with the hardware because that's the sucky part. Okay? So configuration management in these terms is almost dead, okay? Because you don't really need to provision a lot on the machines. You just need a base machine, put it in a cluster, replicate it, and then the orchestrator takes over, It's a very different paradigm for what we're being exposed to right now, We've been mostly dealing with hardware, and we need to stop doing that. We think of like, okay, let me get a new machine, hardware, VPS, whatever it is. Let me get a new machine and we're set. No, talk in terms of services and not machines anymore, because the way it's going to work in 10 years. It's completely different. I will be much happier to think that my hardware is hosted by Google, by Amazon, okay, than by myself, because I really suck at that. And, I think they have the manpower to do a better job for that. And I really like this slide, by the way. So these are my like the last 2 minutes of nerd advices on how we've been running it and how I think you should also look at running containers in production. First of all, they're not better than VMs. If you need full isolation for a specific particular reason, go for a VM. It doesn't make sense to use a container. But for most of the things that we use VM for, like until now, a container would be a better, much more suitable product. Forget about the host. If you can go, to the Google Container Engine, go there. You just upload a bunch of configuration files like the Kubernetes ones, and they'll run the hosts for you. They'll add auto-scaling for you, and you don't have to do anything in terms of hardware. Else, use a very, very good orchestration platform now. I personally prefer Kubernetes because it comes out of Google. The Docker guys have been doing a terrific work on Docker Swarm to provide the same kind of tooling. And then you have Mesos, which is, I think, a more cumbersome way of running, of orchestrating containers. But, I'm opinionated. Run your hosts on very safe environments. You can use like CoreOS. It's a very lightweight Linux distribution. It's security oriented. When there's going to be an update for a bug on the kernel, the machines will reboot themselves. Okay, they will apply patches for you. So like it's a very security-oriented distribution. Use it to run your hosts. It's thought for that, and Google uses them. Google and other big players use them because it's an OS that is made for this kind of stuff. For your containers instead, use like very minimal distributions like Alpine. I could show you like the list of Docker images that I have. And if you start, a Node.js app from Ubuntu, the base image is like 600 megabytes, and you want to kill yourself. You use Alpine, it's like 12 megabytes, and you're done. So to push that image on production is going to take no time versus pushing like a gig of an image up there. Avoid running containers as root. As I was saying, try to use different users. So at the end of the day, those are just Linux systems, so you can just switch the user in the container, because you will not want that if someone can get into the container, it will have root privileges. So as much as possible, try to run them as a different user. Regularly scan your clusters for security best practices and so on. At this link, you'll find a very good tool that the Docker guys have rolled out. It just goes through a shit ton of security, checks to just like make sure that your cluster is running, is healthy, and it doesn't have very common exposures. Isolate colanders like Jenkins in containers. Now, if you can't do it in a VM because whatever, try at least to put them in containers so that it's you don't have to run them on your host, and when they get shell access on your host, they get shell access to a lot of other things, a lot of other passwords, and a lot of other systems. If you do it in a container, it's very easy. There is an image for Jenkins. Just run it there. Because even if they get shell access on a container, that's it. They have shell access to a container. And it's going to be hard for them to go to the host, to escalate to the host. And stop installing shit manually on your system. Try to use Docker images as much as possible, because if you've never heard of Ruby, if you've never played with Ruby or whatever, just pull down the latest Ruby image from the hub, and you have it running, and you don't need to run it on your system or install it on your system. Much easier, much better. Live literally like it's 2016, because containers are going to be changing the way we run apps. They are already changing them. They are changing the way we think of data centers, because now to boot a service, to boot a different OS, to boot a different systems in production, it will take 1 second rather than 1 minute. Okay? Now, I think I'm running out of time. Yeah? No, I'm perfect. 40 minutes, 40 whatever minutes. I kept an introduction for myself at the end, because I think there was a lot on the plate and you might have questions and so on. I'm Alex. You'll find me on Twitter at _Odino_, which sucks so much, I know. But I know someone else in this audience who has an underscored Twitter username. There you go. We're really stupid. I work at Namshi. It's a venture launched by Rocket Internet, the largest European startup incubator in Dubai. I work there as a VP of tech. And you can find me ranting and saying stupid things at odino.org, less frequently than I used to, but still as stupid as they were. Thank you very much. Does anyone have any question? We're good. Yeah. Keep it for yourself. No.
You say in one of the nerd advice
Yeah.
that virtual machine and containers are used in the same. It's really similar.
In?
They are really similar, but they are used in a different situation. How we can decide which one is better?
So the question, I'm just going to repeat it for the registration, is when to decide when to use a VM versus a container. Well, when you run your Node app, you definitely don't need a full isolation of a VM. You will want maybe a full isolation of a VM when you really want to make sure that once you break into that system, it's going to be very hard for you to escalate upwards, Or when, for example, you will want to have like really fixed resource isolation. Now, there is a very nice example there, and it's in this slide. Where is it? Okay, I don't remember. It's one of the links, anyhow. Basically, there's a Quora question asking, like, why did coding.com switch from containers to VMs? Okay, so what they do, they would give you a development environment on the cloud. So you log in through their interface, you got your own machine running on the cloud, and that's it. So you do your development there. Now, they use VM traditionally, but they would be like, very slow to boot up. And then people would be like, hey, I want my dev environment to be up in 2 seconds rather than 2 minutes. So what happened with them, they're like, okay, let's use LXC, even before Docker, let's use LXC, let's use containers. And then they bumped into those issues that I was describing, where resource isolation isn't as strict as with VMs. So, like a container would still go bonkers, would take too much memory, would even won't care about the memory limitation that you've set on it, because back at the time, and even now, it's a little bit buggy, so you can't rely 100% on that. And, it would tear down the whole host, and all the other customers working on that same host, they'd be like, what the fuck, my machine just disconnected. So in that case, when you really need isolation and when you're going to be affecting a lot of other apps, that's when you're going to have problems, For running an architecture, for example, you don't have that problem because you're like, even if I have one host that goes down, I will just set the replicas of my applications to 2, 3. I'll have a set of like 3, 4, 5 machines. And if one host goes down, we have the same apps, the same pods running on other hosts. So in that case, doesn't really affect you, But if you have different customers on the same host and they only have that machine that they can rely on, once it goes down, they're like, it's off. Yeah? Hmm? So the question is if there is a best practice to move a Vagrant box to Docker. Now, do you run one app in that Vagrant box? More than one, okay. I mean, look at Docker Compose. The way it works is I showed you an example with one simple service. So I think, first of all, there is one thing that you can do. You can switch Vagrant to use Docker as, an engine, as driver. I wouldn't recommend doing so. I would just recommend you go with Docker. Do you use Vagrant for dev or in production? For dev. So look at the Docker Compose file. You can specify as many services as you want, and you can link them together, okay? I had specified a web service. I can now specify Redis, MySQL, whatever. What I would do is try to isolate like the way you configure each and every one of those services into separate Docker files, Build those machines, build those containers, and have them running. Once those are running, you put them together in a Docker Compose, and they'll talk. So I think that's the easiest way. Yeah, of course. So the way traditionally Docker works is that they run one service, one process in one container. It's subject to like your opinion and your willingness to adopt that, but generally that's what you do. You don't want to have fat containers that do too much, because these work a lot. These work really well in microservice-based architectures where you're like, I'm going to boot a service, it does one thing well, and I'm going to have X replicas of it. So I would always recommend to just have one service running there. There? Why would I recommend Kubernetes? Because it comes from Google. They're doing this since 9 years. Everything in Google runs in containers. As I said, they spawn 2 billion containers a week. 2 billion is 3,300 a second. So they would know how this thing has to work at scale and what the design of an orchestration tool for that scale would need to be. So the way they come up with the design, it's less straightforward than other tools that you would use, but you realize after a while that, it's been built like this because I'm going to have these problems running this stuff in production. So I think it boils down to their experience. I think they've done an amazing job, and that's why we really bet into Kubernetes.